In this video, I'm going to show you how to work with scatter plots. You'll learn what a scatter plot is, how to create a scatter plot from raw data, and how to interpret patterns of data in a scatter plot. Before we get to scatter plots, though, we need to introduce some statistical jargon. When we conduct a study that looks at only one variable, we are working with univariate data. When we conduct a study that examines the relationship between two variables, we are working with bivariate data. As you will see, scatter plots exist to work with bivariate data. So, what is a scatter plot? A scatter plot is a graphic tool used to display the relationship between two quantitative variables. Scatter plots consist of an x-axis, a y-axis, and a series of dots. The position of the dot on the scatter plot represents its x and y values. Each observation from the data set is represented by a single dot. For example, consider this dot. It represents an observation that has an x value of 2.5 and a y value of 40. Let's work through an example to show how to create a scatter plot from raw bivariate data. First, we need some bivariate data. So here is a table showing the height and weight of 5 starters on a high school basketball team. Let's display this data in a scatter plot. We'll measure the height on the x-axis and weight on the y-axis. Then we represent each player by a dot on the scatter plot. The first dot, for example, represents the first player. From the scale on the x-axis, you see that this player is 67 inches tall. And from the scale on the y-axis, you see that he or she weighs 160 pounds. To complete this scatter plot, we place a dot on the chart to represent the height and weight of every other player. 72 inches tall and 220 pounds, 77 inches tall and 240 pounds, 74 inches tall and 200 pounds, and 69 inches tall and 180 pounds. Note that every player in the table is represented by a dot on the scatter plot. And note that there seems to be a pattern. From the scatter plot, it looks like taller players tend to be heavier. One of the advantages of a scatter plot over a table is that it is easier to see patterns in data with a scatter plot. Let's talk about how to interpret patterns of data in scatter plots. Scatter plots are used to analyze patterns in bivariate data. These patterns are described in terms of 4 attributes: linearity, slope, strength, and unusual features. Linearity refers to whether a data pattern is linear, which is indicated by a relatively straight pattern of dots, or nonlinear, which is indicated by a curved pattern of dots. Slope refers to the direction of change in variable y as variable x gets bigger. If variable y also gets bigger, the slope is positive. Positive slopes go in the direction of an upward arrow. But if y gets smaller as x gets bigger, the slope is negative. Negative slopes go in the direction of a downward arrow. And if the pattern of dots is neither up nor down, the slope is 0. Strength refers to the degree of scatter in the plot. If the dots are widely spread, the relationship between variables is weak. If the dots are concentrated around a line, the relationship is strong. Additionally, scatter plots can reveal unusual features in data sets, such as clusters, gaps, and outliers. Notice how this pattern arranges itself into 3 clusters. Here we have a gap with no observations equal to 5 or 6. And finally, this scatter plot shows most of the observations along a negative sloping line, but there is one outlier in the upper right corner. Let's practice recognizing some common patterns in scatter plots. We'll practice describing scatter plots in terms of 4 factors: linearity, slope, strength, and unusual features. This scatter plot has a linear pattern with a negative slope. Because the dots are closely concentrated around a line, we would say that the relationship between the x and y variables is strong. And finally, there are no unusual features like gaps, clusters, or outliers. Let's interpret another pattern. The dots in this scatter plot follow a curve, so the pattern is nonlinear. The first half of the plot has a positive slope, but the second half has a negative slope. So overall, we would describe the slope as 0. The dots are spread out rather than concentrated around a line, which indicates that the strength of the relationship between x and y is weak, and there are no unusual features. Let's review. Scatter plots are used to analyze patterns in bivariate data. A scatter plot consists of an x-axis, a y-axis, and a series of dots. Each dot represents one observation from a data set, with its position on the plot determined by the x and y value of the observation. Patterns of data are described in terms of 4 factors: linearity, slope, strength, and unusual features like clusters, gaps, and outliers. For example, this scatter plot is nonlinear with a negative slope. The relationship between the x and y variables is strong, and there is one unusual feature, an outlier, in the upper right-hand corner.
That's all, folks.